Problem 28 asks us to describe a pentagon when rotated n degrees is carried onto itself by a positive rotation about its center. What is the value or values of n less than 360 degrees? Well, after we finished solving the last problem and we came up with an equilateral triangle, I'm hoping that we have a clearer idea now of what we need to do. We need to find a regular pentagon. Okay, a regular pentagon is a pentagon where all the sides and all the angles are equal. So let's start off with that in mind. So I've drawn a regular pentagram here, and I've copied it over here, and let's get an idea. Let's take a look and see, does it look like as we rotate around a center point, we're actually going to have the pentagon overlap onto itself? So let's go ahead and try that. Yes. Okay. And yes again. So it looks like that is the answer. Let's take our by now familiar diagram of a point with 5 rays, all sharing the same initial endpoint. And again, let's remember that the adjacent rays are 72 degrees apart. Let me actually write the 72 out there, so we'll be able to see it as we rotate our pentagon. And 72 is out here as well. So let's line up our regular pentagon so that each point lies along one of the rays. And let me tape it in so we've got it fixed to the paper like that. Okay, and now let me take a copy of it up here, and let's rotate the regular pentagon around, making sure that we know the starting point. So let me circle the starting point in red there, and the starting point in red down over here. Let me make it bright enough so that it kind of shows through. Okay, so we're starting there, and we're going to go ahead, we're going to start rotating around and seeing how many degrees it would take. Well, okay, this is 72 out here, so I think you can see the first rotation where they're going to overlap is going to be when they rotate 72 degrees. Okay, so from this red dot to that red dot is 72 degrees. And every subsequent rotation, we're adding another 72 degrees on top of it. So this is another 72 degrees, and now it's on top again. And another 72 degrees, and it's on top again. Another 72 degrees, and finally the last 72 degrees. Okay, so multiples of 72 degrees until we get to 360. And what are those multiples? Well, that would just be 72 times 1 times 2 times 3 all the way until we reach 360. So our answer here is that we have to have a regular pentagon and n could equal 72 degrees, or it could also equal 2 times 72, which is 144, or 3 times 72, which is 216, or 4 times 72, which is 228, and that's about it because, 288, and that's about it because, so let me write these again, so n can equal 72 degrees, 144 degrees, 216 degrees, or 288 degrees. Okay, so let me write a little bit neater down here. If we added 72 degrees again to this, we would come back to 360 degrees. Okay, so we don't, these are the answers then, because we can't, it has to be less than 360 degrees. Okay, and we can't put 0 degrees because obviously 0 degrees would work too, right, if we never even rotated it, because we're asked about a positive rotation, so it has to be a positive number. So these are the only 4 numbers that positive rotation around those degrees will have a regular pentagon that will be mapped into itself.